Hello, Dr. Madhavendra, Professor, Sant College of Higher Education. Once again, I have come with a topic from the subject Project Planning and Evaluation, BBA 302. Topic is how to calculate time expected for the activities under network diagram on the basis of given optimistic time, most likely time, and pessimistic time. After constructing network diagram, time expected, that is TE, for each activity is calculated by averaging time estimates assigned to various activities. What is optimistic time? TO. It is time required if no hurdles or complications arise. This is the shortest time when there is no problem, there is no hurdle. Everything can go as per the plan smoothly, then it is presumed that the least possible time will be consumed in carrying out that activity. Then most likely time, TM, time required in which activity is most likely to be completed. Whether neither so smooth, not so problem. So in between. Mostly it happens. So it is denoted as TM. Last is pessimistic time, TP. It is time required if unusual complications and or unforeseen difficulties arise at the time of carrying out activities of the project. So in next slide, we will discuss that on the basis of input, how we should move on to calculate time expected, or it is also called average time or expected value for each activity of the diagram. We have activity description A, B, C, D, E, F. In numeric, it is given A 12, B 13, C 24, D 34, E 25, F 45. These are the activities of the project depicted through network diagram. Similarly, for each activity, optimistic, most likely, and pessimistic time value have been assigned to. On the basis of this, we can calculate time expected or average time or expected value TE, which is equal to TO plus 4TM plus TP whole divided by 6. Here it is also called averaging. T1 is taken one time, TP is taken one time, but while distributing the probability of the carrying out the activity, maximum time assigned may be given to most likely. So on distribution graph, most likely is double of the summation of the TO and TP. So TO and TP is 2, then 4 times we take the TM. So in totality, we divide it by 6, then we can find time expected. Next slide. One by one we move. First we construct the network diagram. For convenience, at upper left side, we have here taken various activities with its nomenclature and numeric value also. First we construct A, B. A and B, both activities are originated out of the event 1. So A is 1, 2, B is 1, 3. So we are depicting starting from the event 1, 1, 2, A, 1, 3, B. Here A and B are red colored to demarcate slide by slide. Next slide we will discuss to add further two activities in the diagram. These are C and D, C 24, D 34. So C is originated out of 2, which here in this slide is the last for 1, 2, and D is originated out of event 3, which is again last event for the depiction under this slide. Next slide. Before starting, we have changed the color of A and B, which we had constructed in the previous slide, and colored red C and D, which we are constructing over here in this slide. C 24, D 34. Similarly, we move on. Next slide. C and D also changed to color green, and E and F red color. E 25, F 45 means E is originated out of the event 2, but F is coming out of the event 4. But we find that 5 is the last event. It clearly means that the activities preceding to the event 5 will merge together with the event 5. So, we will have the network diagram constructed like this: A, B, C, D, E, F, 1, 2, 1, 3, 2, 4, 3, 4, 2, 5, and 4, 5. It is like this. So, eliminating or wiping out the upper left portion of the information, we can have the diagram like this. Now, here onward, we will move to assign 3 time values, time estimated, that is optimistic, most likely, and pessimistic. What happens in the next slide? It is like this. A means 1, 2 is optimistic time 9, most likely 12, and pessimistic 21. Similarly, in B, optimistic C, most likely 12, and pessimistic is 18. In C, that is 2, 4 activity, optimistic 1, most likely 1.5, and pessimistic time is 5. Similarly, on D, TO4, TM 8.5, TP10, and activity E, that is 2.5, TO10, TM14, TP24, and in the activity F, that is 4.5, TU1, TM2, TP3. It is taken on the basis of the information which we had been given under this table. We can refer it to. Now, going back to the diagram where we were discussing, here now time expected, that is TE, is calculated by averaging these 3 values assigned to each activity. Next slide is how we calculate. We take one instance, that is 1, 2 only here for calculation. For example, from 1 to activity that is also called A, we take all the 3 values in this slide. So time activity A, that is 1, 2, taking activity A, that is 1, 2, to calculate time expected TE by averaging TO, TM, TP as below, it comes after calculating 13. So time expected for the activity 1, 2, that is A, is 13. Similarly, time expected of other activities, that is B, C, D, E, and F, can be calculated as shown on the next slide. So this is now a clear picture. We have diagram 1, 2, 3, 4, 5, A, B, C, D, E, F, and for each activity we ultimately calculated out time expected for A, TE 13, for B, TE 12, for C, TE 2, for D, TE 8, for E, TE 15, and for F, TE 2. We can write it like this also, eliminating out A, B, C, D, E, F. Finally, the depiction of the network diagram after constructing on the basis of input we have and after calculating the time expected on the basis of three time estimated assigned to each activity, we find ultimately this is the final shape of the network diagram, assigning time expected to each and every activities. I think it is clear now. In next part, we will further discuss about how to calculate same thing with some other example and some other problem also. Thank you.